All right, so here's the intro for ICP 429. Here it is in Jira. So, might not make sense what this is all going to be about, but it will in a moment. So, we have a utility, and it's the upgrade checker system. So, the upgrade checker system lives in this UpgradeUtils file, and we'll go over that in a minute. And the current two functions that this UpgradeUtils file does in terms of checks for tables is a column check and a foreign key check. So we need to add support for additional types of checks. We want to make sure do schemas exist in the database? Do tables exist? So our column checker only checks for column types and that column specific items exist, but not the tables themselves. So if, for example, if we have a table that is supposed to exist that does not, we will be unable to add columns to it because you can't dynamically add a column to a table that doesn't exist. You have to create the table first. And that's something that UpgradeUtils does not do yet, does not create tables. And we have some other stuff, but this intro video should get you going on the basic requirements that we can get into more advanced items like aggregates and indexes and rules. Actually, I said advanced, but they're not really advanced. They're probably one of the simplest, the aggregates and indexes and things like that. So we'll dive right into the code. We're going to check out this upgradeutils.pm. And so I'm already on VBox Ivan. So UpgradeUtils, it lives in a directory of many other utilities. So we'll just check that out for a moment. So anything IntelliSoft related is going to live in, that's IntelliSoft Perl, is going to live in user local, or IntelliSoft system lib any Perl. And these are going to be libraries that can be used for any Debian distribution, any Perl version. We don't have to do builds like cpan or something like that. cpan is a whole different topic. We won't need to go into that just yet. Anyway, so we're going to look at UpgradeUtils. So UpgradeUtils does a whole heck of a lot. We're going to ignore most of it, and we're going to check the tables function. Check the CheckTables. So here's the two things that I said that the table checker currently does support. It does columns and foreign keys. And so what we're doing is we have metadata, and that metadata defines what is supposed to be in the file. So I'm going to split my window and open one of those metadata files. One of those metadata files exists in modules core db. Our main schema is asterisk, and we have asterisk.tables, and it's going to be .json. So the full path is there, and this is the metadata for what should exist in the database. So we use Postgres. So the first element, we have a hash, and it's going to be table names. So and then underneath that, the very first item is going to be columns. So actually, I'm going to have to pause this for a second. This is the wrong file. Okay, so here's what we got going. I previously did tables.json. I apologize, that's the old style. It's going to be an entire directory. So it's the name of the schema, also the name of the schema, .tables, and then inside asterisk.tables are the individual table files. So we're going to look at, let's say, auto answer groups.json. So the previous file, completely ignore that. That's an old style we're not using. So what we have is and I'll show you the name of the file again, auto answer groups.json. And so in this auto answer groups.json file, what this means, it's the table as part of the schema. So Postgres supports basically namespaces, right? So we have the asterisk namespace. Inside the asterisk namespace is the auto answer groups table. So inside the JSON metadata, we have the listing of columns. So its first item is a hash, and inside the hash is columns. We have primary key. If we have foreign keys, they're exported here. even though we have an export for foreign keys, we don't check them yet. So what this system's going to do is it will look at each one of these columns inside this auto answer groups table and make sure they exist. If they don't exist, it's going to use the create syntax. And then if they do exist, but they have the wrong type, it's going to make a note of it. We don't have automatic type conversion. Don't worry about that. That's a different project. And if they do exist but have the wrong default, it's going to set the proper default. Then we'll get into some specifics on how to test these things. I'm going to go back to the UpgradeUtils file. So I'm going to give you an example of CheckTable columns, which conveniently is right below us. So this is the old version. So hang on, I'm going to pause this and update. Okay, so I've updated the correct version that we're supposed to be using for CheckTable columns. And so for CheckTable columns, we have a really handy function which takes a callback, CheckTable for each. So our system has a dependency mapping and multiple modules and all that. A lot of that magic is done for you. So CheckTable for each is going to do for each and every table in the system for every schema. It's going to hand you that data. So we have a callback. So every time this callback runs, it's going to give you the name of the module, the name of the schema, the table, what metadata are we officially supposed to have, and what metadata have we installed. And this is an old style, slightly older style. Metadata have is really metadata installed, just for clarity. So if we just mentally substitute, right? So we have the official, if we were to exactly replicate the official metadata, that's what we're supposed to have. And then the metadata that we have, or the metadata that's currently installed, might be wrong. Might be missing a column. It might be missing a table. It might be missing a foreign key. And we want to know about that. And we want to fix it automatically if we need to. This is basically part of our upgrade system to ensure consistency across all of the systems we deploy. So the name of the table, this is just a duplicate variable, nothing fancy. So we need to check this table, and the metadata that were passed, because we've asked for the columns metadata for the check table for each. So it's going to specifically do a check table for each. The metadata official might have more than just columns, but at the bare minimum, it will have columns. And then the metadata we have should also just contain columns. So that's really the only stuff we care about. So that's what these two are about. So the metadata that we have, aka installed, this is the columns that we have installed and compared to our official columns. So then we go through each one of them, and then if we don't have the thing installed, this local is just an alias basically for the metadata we have, and we're going to compare and check for differences. So we have a missing table, so we're going to create the and I'll bring up that metadata file. We're going to create the column based on the official metadata. So this hash is going to be that we got from the ref to columns, right? So we're accessing this, and then we know the name of our column, and then we're just cycling on the keys of the hash. And so the first one, I mean, if we can't validate that it's going to be sorted in this exact way, so we might not exactly be operating on auto answer group name, obviously. But assuming we were operating on a sorted list, this would be the first one, and we're going to create referencing the arrow create, which is right here. So hopefully that should be obvious. If we have a failure, obviously we're going to note that. And then there's a bunch of internal error handling, even though we're not doing like handling here, we're not telling you about the output of what query failed. DB execute will do that for you. So don't worry about error handling. And also there's end of our loop for each column. So now actually towards the end, we're not out of the loop yet. So here's our type checking, and then here's our default checking, and we have two options. So one is we're gonna check only, and that's the -CT option that's in the Jira ticket information, and we have CTF, which is check tables and fix. So if we're not fixing, we're just gonna note that there's a problem. So we're gonna note that's a problem. If we're not fixing, we're just gonna skip it. Sometimes I do debugs just to help with that verbosity, and more fixes, and that's it. That's the end of our. We're matching the end of check table columns, and this is the end of our callback here for each, and then here is the end of our for each column. So we basically, do this on every single column, and I'll go over foreign keys. So we can go back to our check tables. We're going to do check table foreign keys, which is the very next function. And we have simpler body. I've kind of modernized this to do, clean up the loop a little bit, make everything handled by an extra function. This is a good style to use going forward. Check table foreign keys. Same check table for each, except we're going to pass in an include of FK for foreign key data. And so we have our official versus installed. Sorry for scrolling. If we don't have either one, then nothing to do for whatever reason. Oddly enough, I think that was just for testing, because I don't think we'll ever really have a situation where we don't have either one. Because the reason why we're here is because we either have something installed that we need to check, or we have something official that we should check. So that should both never be true. So the check table foreign keys, very, very similar to the check tables. And this is going to check an individual table. So on a per table basis with their metadata, it's going to check all the foreign key data. So we have the name of the foreign key. If we're missing, if we don't have it installed, because we operate everything by name. So, we have the name of the official one. We have a direct reference to the metadata. And I'll give you an example for the, so auto answer groups JSON does not have foreign keys, but we'll find something that does. I know for sure that, let's say, trunk groups .json is going to have a foreign key into trunks. Maybe not. I'm going to pause and we'll find one. Okay, so I should have been in trunk groups. I think, so you ignore that last part. Trunk groups should have a foreign key. I guess I'll fix that in the back end. Anyway, so I found user. The user table definitely has some foreign keys. This is the FK, start of the FK hash in the foreign key table. All right, we'll pause there for a second. So the user table definitely has some foreign keys, and we'll go through the checker. So this one's a little different. We use data compare, which is really awesome. It will do a deep compare for anything that's different in a definition. So want to know if any of these conditions, parameters of the key are different. So like local columns on delete, on update. It'll let you know it's more than just does it exist. Does it exist, and is it correct? And we want to know that. So we do some modifications. Because otherwise the screen's really wide. We add some new lines, and if we do a data compare and it's different, test differences color is really nice side by side, and it will show you a match. We don't have a fixer yet. So it would be ask to fix this. And we do have a prompt mechanism. We'll go through that in a moment here. We just got it. So when we do the reverse check, what local things do we have that were not officially installed? So this might be somebody was doing a development on a production machine. We could be checking a developer machine. We could be checking a customer machine. And for whatever reason, there's a foreign key that we don't have officially. So it's either left over from an upgrade. There was an upgrade that never happened to remove it, or maybe a developer forgot to include the upgrade. So that does a prompt. Remove extra foreign key, yes or no. If we have some helpers, check as yes. So a yes is a Y, a 1. If somebody types YES, uppercase or lowercase, there's lots of different ways you can get a 1 or a yes. So if we have a true for that, we're going to execute a drop. Probably, yeah, we could add a drop in here, just as a convenience factor. That would be nice. We only have the creates. So it's a to do is use drop from the metadata. There's nothing wrong with this particular way of doing it, but just to be consistent with, just using the metadata, probably not a bad idea. And so that's the end of checking foreign keys. So here's how we check it. How does this code actually get used? So there's some examples in the ticket here. So we'll go over this next. So testing. So we'll say, whoop, it went into edit mode. Sorry about that. So testing, we're going to deal with the CT option. So you don't have to worry about what any of these options do, but the CT option at the very end does a check table. Precede it with a /. So we just run that. And so, yeah, so CT should not be asking to remove. It should just be noting that. So we could actually fix that real quick. So it says remove extra FK, foreign key. So we don't want to be prompting for removal if we're not doing a check and fix. So yeah, so we'll just do that here. Right, so this should make sense. We're only going to be removing prompts to remove if we're going to do a check and fix, which is the CTF option, which we did not pass. Okay, so here's all the mismatches. So it's going to say extra foreign key that's not officially installed, and it's going to give you table column mismatches. You know, our current type is integer, and we're expecting a type text. So this is a great. It's inconsistent for a reason. It's so that we could test the fixer stuff. And then here's some of the things: table column missing, and so that's that previous function that we just went over. So if we do a CTF, it's going to attempt to fix some of these things. So I'll let you run through that just so you know how it operates on fixing. And then what do we have in terms of columns that we have issues with? Well, so let's just say if we go into IntelliSoft Modules Core and we go to asterisk dot tables. So let's just say we make a new table. So we say, I'm just going to copy, this is a small one, db.json. So I'm going to make whatever, foobar. Foobar.json has, this is perfect. This is a great example. So we're just going to ensure that we have a key value columns. And like I mentioned, primary keys are not checked currently. So we're going to save that. And if we do a CTF, there's a bunch of failed, and not only the foobar is going to fail, but a bunch of other stuff is going to fail too, because it does not create tables. So here's the beginning. And here, right away, table column missing. So we didn't even have to add foobar as an example. We have plenty of existing examples. So our checker says alter table core meta constraints add column. Well, core.meta constraints doesn't exist. So that's a problem. So our very first item to work on in the to-do list here is so we have schemas, which we don't have to do first, but table create. This is high up in the checklist. So as you get each item, you could just you're like, hey, got that done, or hey, it's not done. You could uncheck it. So we're gonna work on table create first. So what we could do, we don't care about foobar.json anymore, and basically in the check tables columns, we want to add another checker. So we're going to do check tables, and we're going to pass it our DB. $DB is a connection handle and a class. It's the simple DB class. I'll paste that in the notes if you want some info on how to write queries using the $DB handle. But basically, we want to have another one of these functions that does checks. And we're going to take in our DB handle and table column. So we want table consistency. So check to make sure tables exist. And so this is going to do a check table for each. And I'll give you an example here. So we want tables from the metadata. And it's going to give us, I'm going to borrow from the foreign keys because that's more modern style. So we're just going to literally copy the body. There you go. So we have a check table for each of tables. So we're going to do tables official, tables installed, and it's going to be tables. We really don't need this check because, like I said earlier, I can't see a reason why both would be undefined because we have to be here due to a table somewhere. We either have the table installed or the table is not installed and we have it officially. And we're going to do a check table. Just literally going to just do check table. And then tables official, tables installed. So this is going to be a hash. And each one of the hash members is going to be the name of a table. And then we're going to have a sub check table, which is going to be very similar to the check all table foreign keys, which is here. And we want to have a very similar, we don't want to copy all of this, so we'll just kind of copy the body. And we'll start with here. So, table name, right? So our hash members are table names from our tables official, tables installed. Tables, and we're gonna, these are now, I'm gonna search and replace with table name official, right? And then, so now we have this, so, you know, checks, you know, does the table exist? Do we have extra tables? And you could borrow, you know, the style from, you know, C for design form style. And then we're going to use the Postgres info Perl module, which is noted in here. Postgres info. There's lots of really good goodies in here. So we could ask for various things like, get me all the indexes. So it says and more. So we're gonna load that Postgres info, and we'll look for tables. So let's say get table something something. We'll see if get tables. Look at that. So there we go. So we have Postgres info.pm get tables. So we could literally just do oh, this is not in the right place. We're still gonna need get tables, but we need to in the for eacher, check table for each, we need to handle support for getting the table metadata, get tables. So we need to add support for this type of include for check table for each, and that's where we're going to do get tables. Yes, that's where we're going to do something like get tables, which I think we already do. So we're going to look at this check tables for each, which is right here. Possible options. So now we're adding a new option. So it's going to be tables. And FK, it's the name of our option is FK, not FKS. Anyway, so now we have tables that we could pass. And then so what this does is it does a loop for the modules and schemas. And this is all the magic stuff to traverse the database and give you all the tables. And we actually already do this, so we don't need the get tables call that I mentioned earlier, because we already call Postgres info get all table columns detail. And we put it into columns for the specific table. And this is what that looks like when we populate things like columns in FK. So this is on a per table basis. We have the table detail installed, and what's official. Official comes from those JSON files. Installed comes from anything that's install related comes from Postgres info. So we'll go down and look. And this is the for each callback. So here's the stuff that we, the official stuff is that we need to make sure is there. And the install, this is stuff that we have already. And we basically are giving it the table name. So this should actually be a really easy check, because the compare table is going to be based on this callback gets called no matter what. If it's not an official table, but we have it, this callback gets called. Because we have a merge that happens up here in the tables we need and the extra tables that aren't. So this should be a super easy check. So we're going to look for check tables. So literally, in your check table, right, if the metadata exists in official, we need to make it. If the metadata does not exist in official, it's extra. And then so we want to prompt the user. If we want to anything removal based is going to be a prompt. Anything that's just a fix, like creating a table, is not dangerous. So we could just go ahead and create it using the we could literally just do a create table with no columns, and then the column fixer will add the missing columns. So this is pretty much the end of the intro. So these are like the to-dos. I saved all of this on the VBox, and there's notes about the other things that would have to be added. We'll get to that in another session, because it's going to involve a little bit more work for when we work with metadata that comes from the JSON that we don't have yet. So we do not export indexes. We do not export rules. So we'll need to talk about that.